Well, thank you all for coming. I'll talk today about creating reproducible dynamic analysis documents in RStudio. Now, the main goal of the presentation is really to introduce and to promote the use of R Markdown with R and RStudio as a computational framework that supports both R and Python for creating dynamic analysis documents that combine coding, mathematical expressions supported by LaTeX that can be used to support mathematical modeling with a wide range of applications, from probability and statistics to computational calculus, linear algebra, differential equations, and modern data science. This technology allows us to create professional project reports, lecture notes, randomizable exams, presentations, and even publication quality papers, blogs, and websites. And for me personally, it's been a one-stop solution for all my teaching and even research needs, because you can also create articles using the articles package. Now, and also the book down formats for articles. So the goal is to illustrate this relatively new technology with several modeling projects, which I'll share with you on the RStudio Cloud. Hopefully that would encourage at least some of you to kind of have some hands-on experience with this technology. I will also share several other documents. I think I will share basically 5 documents: Introduction to R, Introduction to R Markdown that I wrote for my students. Also our Primus paper dedicated to the same topic, along with the supplement that contains the complete code for all the examples based on R and Python. And I will actually give you later a link to join the RStudio shared space that I've created for this presentation. And this is where you see all the documents, and you'll be able to download them, play with them, both Markdown documents as well as PDF and HTML documents. Now, before we get there though, let me say a few words about the main software that we're using. So this is R with RStudio, but if you want to create PDFs, you're gonna need also a TeX distribution, either the full TeX distribution, like MikTeX or MakTeX, or the TinyTeX R package, in addition to R and RStudio. I believe though recently, the first time you create a R Markdown document, TinyTeX is installed automatically, so you don't have to worry about that. I will share this presentation, probably a PDF version of this presentation, so that you can have access to all these links. In particular, here I have links for MikTeX, MakTeX installers, R and RStudio installers. So this is if you want to install the software on your computer locally. Now, the RStudio Cloud, though, provides a cloud-based option, and they offer free accounts as well as paid accounts, but they're very reasonably priced. They also offer an instructor's account that allows you to create virtual classrooms and shared spaces. And I've been using great success RStudio Cloud over the last couple of years, anytime I had sort of computational needs in remote teaching. Now, in addition, RStudio offers an R interface to Python via the Reticulate R package, which provides a comprehensive set of tools for interoperability between Python and R. So you can use both R and Python in the same R Markdown document, combining the power of both. Now, I already mentioned with R Markdown, you can create websites, blogs, books using the Blockdown and the Bookdown packages. And I'll give you some links to explore all these topics shortly. Now, it's worth mentioning that the instructor's account in RStudio Cloud also offers Jupyter notebooks you can create. By the way, the Jupyter notebooks that probably you've heard about that support not just Python, but also R, Julia, and other programming languages. In fact, so the name Jupyter comes from there: Julia, Python, and R. The Jupyter notebooks are also based on Markdown, and they're sort of similar to the R Markdown notebook. So they're both based on the same technology. Now, I recently learned from the RStudio team that RStudio Cloud is expected to release a new collaboration feature for shared projects in RStudio workspace. That will be very much like working with Google Documents, meaning several people can work at the same time. And that will be very useful if you're working on a student project and the student is present so that you can kind of work together. And this is coming very soon, I was told, maybe within a month. In addition to the basic software R and RStudio, I want to just emphasize and advertise a couple of R packages developed by Project Mosaic. Now, Project Mosaic is a community of educators working to develop new ways to introduce mathematics, statistics, computing, and modeling to students at different levels. And you can check out their websites, even though it's still under construction. Now, I personally completely share the vision of Project Mosaic for the future of computing mathematics education. Project Mosaic, in fact, is behind the development of the Mosaic, Mosaic Calc, the GG formula, and several other packages. And they're really designed to facilitate the use of R in statistics, even calculus level. And a good reference is the UMAP paper by Daniel Kaplan, Cecilia Bokovic, and Randall Proin, modeling-based calculus with R and Mosaic that you can find in the UMAP journal. Now, I personally have been using these packages for computing at any level. I've taught several times a calculus lab with R. I've been developing over the last couple of years introductory statistics with R. We developed a course on computational science with R and Python. And so this is the low level. At the upper level, courses in deterministic, stochastic modeling, mathematical finance, applied statistics, data science, and so on. Now, just, of course, the best way to see our Markdown is to play with our Markdown inside RStudio, and we'll do this shortly. But just to kind of give you, the big idea, our Markdown is actually it's a Markdown, so it's plain text formatting, as opposed to HTML, which is a markup language. LaTeX, by the way, is also a markup language. So both, as you know, LaTeX and HTML are very dense and sort of difficult to read and work with. And that was the idea behind creating Markdown language that really simplifies formatting using plain text. The idea is to easily create publication quality documents, presentations, reports, articles, websites, blogs, everything really. And it allows you also to embed chunks of R code or Python code. And when you compile the Markdown document, when you knit it, as we say, then you can create an output that will contain the plain text, LaTeX expressions, the result, numerical and visual from your code, and everything will be automatically embedded into the final output with publication quality. And there are many actually available output formats, including HTML, PDF, Microsoft Word, and PowerPoint presentations. You can create Beamer PDF slides, HTML slides. This presentation is an HTML. It's actually IO slides, HTML presentation that I created with Markdown in RStudio. There's an extended support for tables, figures, bibliographies with the Bookdown package. You can create even HTML books and PDF books using this technology. You can include LaTeX, but in a much more simple way than a proper LaTeX document. You can even create interactive documents using Shiny. And here's a list of links that you have access once I share the presentation. And these are all freely available. Our Markdown, the definitive guide. I highly recommend this book, Creating Websites and Blogs with Blogdown, Creating HTML Books with Bookdown, Bookdown websites. And this is a link to a lot of Bookdown books that are available. These are HTML books in different fields. So they've got a lot of books over there and everything is free. This is also a very useful book, the R Cookbook, which is also freely available and so on. So you can export these links later at your convenience. Now, just to finish this part of the presentation with some tips, I kind of learned the hard way over the last couple of years that if you expect that the students could sort of install all this software on their own without any problems, well, you'll be mistaken. There are many issues, and if I start listing the issues, I can actually take the entire presentation just talking about all the issues we came across when students were trying to install this software. So one good way to avoid, of course, in person, we do have all this software. If we're teaching in person, we do have all the software installed in our computer labs. But one way to avoid most of the software-related complications is to have the students use the RStudio Cloud, which offers free accounts. Of course, with sort of limited time, I believe up to 25 project hours per month. But for an additional $5 a month, the students can get up to 75 hours and so on. Now, scaffolding the project is certainly something absolutely necessary to do by just sort of giving them initially even complete solutions and then gradually asking them to add some code. And even though we don't require any kind of prior programming experience in R, the students are expected to learn quickly the basics of R. And I've written a tutorial on both R and R Markdown, which I'll share with you. Now, so the first project that I wanted to kind of use to illustrate this technology is a water cooling project. But the idea is not to go through this project, because that's not really the main purpose, is to kind of explain the mathematical and the computational details behind the project. Is really to give you an idea what it means to implement a project using R and RStudio, so that you kind of get a sense, for example, what it takes to implement various parts of the project. And by the way, this example is based on a paper by Daniel Kaplan, one of the authors of the Mosaic and the Mosaic Calc packages. And this is from his UMapp paper, Is Cooling Exponential? And this is based on the Mosaic, and all the functions I'm using from the Mosaic and the Mosaic Calc packages. So the Mosaic package, in fact, comes with data called cooling water. So you don't have to upload any data. It's already available in the package. Once you load the package, so once you load the Mosaic package, the data becomes available. And if you want to create a scatter plot of the temperature against time, you use the gf_point function for scatter plot. This is a formula object. And then you provide the data, which is the cooling water data, which is available from the Mosaic package. And everything else are optional arguments that you don't even have to write. I put them there just to show you how you can fine tune things and have a publication quality plots. And this is the plot, that you get, the scatter plot of the temperature against time. So basically you can create this with one line of code. Of course, as we all know, the solution to Newton's law of cooling, this mathematical model here for the temperature is a function of time, then you can fit the data, because we have time data and temperature data. You can fit this model to the data, again, in pretty much one line of, actually in exactly one line of code. And this is that one line of code using the fit model function from the Mosaic package again, where you write a formula object that basically implements the mathematical model. This is temperature as a function of time that comes from the solution of Newton's law of cooling. And we have two parameters, A and K. The A actually is the ambient temperature, and K is the cooling constant. Then you provide the data, and of course, it has to be the case that the temperature and the time variable, these names are the same as the names of the corresponding variables inside cooling water. Let me zoom. I think something happened with the Zoom. Let me go back. Okay. And then you have to provide, because behind the scenes, this is a nonlinear least squares, you have to provide initial values for the parameters. And in this one line of code, you get a fitted model, actually, not just the fitted parameters, which is typically the case with various linear least squares or nonlinear least squares function, but you get the fitted model. And so it returns a list basically with a function, which is the fitted model. And now on the top of the scatter plot here, there's only one more line of code. So T is, if I go back to the previous slide, T is basically the fitted model here, which represents an R function. And then you can just plot this as a function of t by providing a range for the variable, the independent variable t. And in just one line, this one line of code, you can add now the fitted model in red, superimposed on the top of the data given by the blue dots. So that's what it takes. Now, of course, as you can see, this is not a very good model. And the reason it's not a good model is that there are actually two cooling processes that are involved. One is that one comes from the water evaporation from the top of the open surface, and the other one is sort of the heat exchange from through the walls of the container where the water is. Right? So to accommodate that, you can use actually an exponential mixture model where a sum of two exponents that represent the two cooling processes. One is slow and the other one is faster. And then the only difference is that you kind of figure out now the initial guesses for all the 5 parameters that are involved. And then again, use the feed model, temperature. This is sort of the formula object. And this is the new model with the sum of the 2 exponents using the same data, of course. And now you provide initial values for the 5 parameters. And you get basically a perfect fit. You get basically practically a perfect fit now to the data with this exponential mixture model. In just a couple of lines of code, you can export the data, you can fit a model, and then you can make conclusions and so on. And this is actually the fitted model here. For convenience, I also showed the fitted parameters and the full fitted model. Now, it's also easy to find numerical solutions to systems of ODEs using the integrate ODE function from the Mosaic package. And all you have to do is provide a formula object that sort of specifies the right-hand side of the differential equation. And here, just to give you an example, I'm using, again, sort of the original Newton's law of cooling differential equation with some specific numerical values for the ambient temperature A and the cooling constant. So you need to specify, obviously, the initial temperature, which you can get from the data, and numerical values for the parameters that are involved in the differential equation. And then you need to provide a range for the integration and integration step. And actually, so what is being returned here in the solution is a list. And in this list, there is a function t, so that you can extract using the $sign from the list. And that's an R function, which is a continuous function, which is done with the spline interpolation. And then you can just plot this function as a function of t using, again, the slice plot as before. In this one line of code, you add to the previous line of code that we use to plot the data, and you get the result that we've already seen before. It's also very easy to create direction fields. And for that purpose, you can use the pragma package, which stands for practical mathematical functions. And the key function is the vector field function. And here I give the signature of the function with all the variables, but this is how you use it. And for this, I'll use an example from Kurt Bryan's text, Differential Equations, a toolbox for modeling the world, which is the text promoted by Simeo that I use myself in our mathematical modeling class. And I really liked it. I highly recommend it. So this is also an example of Newton's law of cooling, but now the ambient temperature is not constant, but it's a periodic function of time. And this is the precise function. So the cooling constant is 0.2 in this case. And this is the chunk of code. That's all it takes to create the vector field. Once you load the pragma package, you need to define an R function as a function of t in u. And this function represents the right-hand side of the differential equation. In our case, that's the function. And then you provide ranges for the independent and the dynamic variable. And using the vector field with this function, that is the right-hand side of the differential equation, ranges for the independent, the dynamic variable. The scale controls the size of the arrows. Entity controls the grid size. Color is optional. And you get a vector field. And of course, all these visualizations are automatically embedded into the final document, which is how I created this presentation. I didn't have to insert any images, nothing really. And so, of course, there's also, you can use fancy ODE solvers like the RK4 Solver to find numerical solutions to all these. And this is also based on the Pragma package. So for example, on the top of the vector field, you can find a numerical solution. And notice that again, just the same function f that specifies the right-hand side of the differential equation is used. And these parameters kind of, this is the initial value of the dynamical variable, number of steps, the interval of integration from 0 to 20. It's very intuitive. And then the solution list, you can extract the x values and the y values, and you can plot the lines on the top of the vector field. And in 3 lines of code, you create the vector field, and you can visualize the numerical solution on the top of the vector field. And of course, you can visualize a whole family of solutions on the top of the vector field if you use a simple for loop that allows you to update the initial value for the numerical solution so that you can get this family of solutions. And I just kind of want to show you very quickly, this sort of couple of packages, the Mosaic, Mosaic Calc, and the Pragma packages that you can use to great benefit that really allow you very quickly to implement numerical solutions to systems of all these, to visualize direction fields, numerical solutions, and so on. And now, at this point, I think it's time now to go to the RStudio Cloud. So we can play a little bit on the RStudio Cloud, hopefully. And for that, I will now share a link, which I will put in the chat. This is sort of an invitation link that you can click, and you have to create a free RStudio account, which you can do in seconds because they're only asking for first name, last name, and email. So here's the link. I'm putting it in the chat. So click on that link, and it will prompt you to create an account with RStudio Cloud. Again, it takes seconds. First name, last name, email, some password. And then choose the option. They'll give you some options there. Choose RStudio Cloud, not Shiny, for example. RStudio Cloud, and then you become a member of the shared workspace that I've created on the RStudio Cloud. So let's see, and let me know if there are any issues. Oh, I already see 1, 2, 3. I already see 3 people there who have joined the workspace. And I will stop sharing at this point. Wait, actually, what do you see now? Because I think Zoom is sharing my entire browser. So even though I switch tabs, I think you probably also seen my RStudio Cloud account. Is that right?
Yeah, we see the RStudio.
Okay, excellent. Thank you. Okay, good. Okay, so let me refresh here to see if more people. Okay, 1, 2, 3, 4. How many will get? 13 participants, 12 without me. Well, I suppose there's no need for everyone to join. You can just watch. Somebody could be on a mobile device, a phone. Obviously, then they won't be able to do that. So at this point, should I wait a little bit more or? Okay, so I see someone already clicked on the project here, the creating dynamic analysis documents in RStudio. When you click on this, you create your personal copy, a derived project, right? That you can work with that doesn't affect the main project. So so I will click on, I will enter then my copy. Enrique created a copy. Okay, so I will enter the main project. Okay, so we see what you see right now. So it's deploying basically RStudio on the cloud. Okay, and this is RStudio. This is RStudio on the cloud. So let me actually close everything. So let me also clean maybe a little bit things. Okay. So initially, actually, you're gonna see when you enter sort of some information about R version and so on. Now, this is the console here, and you can use it as a calculator. 1 + 1. You can compute various things. You can use it as a calculator, but that's not how we are going to use RStudio. So we're going to use Markdown documents. Now, the way to create a Markdown document is you click on this plus button here and you see our Markdown. So you choose our Markdown. You can also create presentations, by the way, here you see presentations, and that's how I created this presentation. So I use the HTML IO slides. There's also HTML slider. There's a PDF beamer, even PowerPoint, if you like PowerPoint. You can do that as well. So actually, you know what? I think you're going to be more impressed if I create a presentation, an HTML presentation for you in 2 seconds. Let me do that now. So, so this is actually Markdown document that is being loaded. So that's just a template, a title, output, IO slides presentation. This is a header for the Markdown. This is some global options that you can ignore for now. The hashtag, single, double, triple, and so on, are different levels of headers. You can insert, obviously, you can just type some plain text, hyperlinks. You can do sort of lists, plain text formatting. You can insert a chunk of code. That's chunk of our code. And the way to insert a chunk of our code is you can actually click on this C button here that says R, and that inserts a chunk of empty code. So, you know, you can do various computations here, sine of 2 times pi, you know, divided by 3. You can click this, the green play button to execute, to compute that, and so on, right? So you can display the code or you can suppress the code in the final document. There are many, many, many options. You can create publication quality documents, of course. So there are many options for fine tuning that are kind of hidden here. Echo set to true will display the code. Echo set to false will suppress the code, and you only see the result of the code, whether it's numerical or graphical. And then once you're done, you can click the knit button to knit that document, but first it will prompt you to save it. So I'm going to save this as a test, and it's going to be saved in our project directory, which is, by the way, on the right-hand side. And now you've probably not seen, but a window popped up with an HTML presentation. And you can do the same thing yourselves, of course, if you're working inside your copy of this project. And that's that. Okay, and you can actually see the presentation right here. If you look on the right-hand side under the files directory, this is the Markdown document that I created test, and this is the presentation HTML. If you click on it, you know, you can actually view it in the web browser, which is exactly what I was doing with my own presentation. All right, so that's it. That's how you can kind of create Markdown documents, and you can then create from them publication quality documents. Of course, in addition to presentations, you can create a sort of a proper document. So I'm going to do a PDF this time. I'm going to put my initials. You can change this later. Okay, now this creates another. You see, it's basically pretty much, it's actually the same template. The only thing that is different is the output. Now the output is a PDF underscore document. And this is the header. You can change the strings, of course, that are in green. So the title, you know, author. There are many, actually, many options also for the header that allow you to create, you know, really, again, publication quality documents with fine tuning and so on. But these are things that you kind of learn gradually. You can start from that. And again, you know, if you need this document, I have to save it again, test2. And then it will create a PDF document that pops up now in a window in a PDF viewer that you don't see because you only see in my browser. And it, you know, it's sort of already kind of almost publication quality without any fine tuning. Everything is nicely organized. And you can see it also here, the PDF. If you click on the PDF, it will actually open right. Oh, so now you can see it because I open it in the browser, right? In a new tab in the browser. And so that's what you see. So you see the code here is highlighted in this sort of, is shaded in this gray window. Then numerical result of the code, you see graphical results of the code, and everything is automatically embedded. And you are ready to, with sort of a, you know, professional quality project report. And again, that's what I've been doing for, like I said, for all my teaching and research purposes. Yeah. For lecture notes, for exams, projects, articles, everything I do that way, one-stop solution. Now, in fact, the source code for the presentation I have in this file called Senior Expo 2022 RStudio Cloud. So if you click on this document on the right-hand side, it will open this Markdown document. And this is actually the source code for the presentation. So all the links, the code for the projects, everything is here that you can play with. So for example, let me run a couple of chunks of code for the water cooling project. So here, the first chunk will basically create, I guess it's better to run the first chunk, which suppresses warnings and messages, so that you kind of get, you don't get these warnings and messages. So if I run it again, they will disappear. So this is what you see. And this is a good way to kind of interactively develop these documents before you compile the final document, so that if any errors, you can kind of figure out as you go. And that's very good debugging practice, rather than sort of putting everything, you know, and only then at the end compiling and trying to resolve all the errors that you may be getting from syntax. Usually the students obviously make a lot of syntax mistakes in addition to sort of more fundamental coding issues they have, but the syntax errors are the most common. You can now let me run this chunk of code, so you get that, and so on. So you can play around with that. This is how you fit the model in one line of code. This is the function T, the fitted function. Now superimpose here on the top of the data, and so on. So you can play with that. And you can download all these files that I've shared with you. So for example, if you, and here is also, I have an introduction to R programming. This is what a tutorial of 22 pages that I wrote for my students in Markdown. It sort of, it covers really the basics of R. And I've been using it for, you know, any class that I use R, give it to the students to go over. Another document that, and I also posted, by the way, the Markdown, the source file for this introduction to R, so that you can use it, you can adapt it to your needs, and it would be easy. And sort of, I thought that would be handy. I also have here our Primus paper, which, let me open it here. And the Primus paper is also on this topic, creating dynamic documents with R and Python as a computational visualization tool for teaching differential equations. So we actually created this paper again in RStudio, but you can generate a text file actually also from the Markdown document, and I use that text file for the journal article, but you know, they sort of remove some of the formatting, so that's why it's not exactly the original formatting, but still that's how we prepare this article. So there are more examples here, mostly related to differential equations. And at the end, there is a SIR example implemented in Python. And I'll say a few things about Python as well. Now, there's also a supplement that comes with the paper that you can get, which kind of, again, this is done in Markdown, based on a Markdown document that has the complete code for all the examples, and it's some even additional actually examples to kind of illustrate things that hopefully you find useful. Now, after that, there's the R Markdown Workshop. So this is a tutorial of 15 pages that I wrote for both students and faculty in the department interested in learning Markdown, R Markdown in particular. And so it kind of goes over the main features, how you can format things in Markdown, as well as, you know, you can insert images. We use this now with remote teaching. The students will take a picture with their phone, and that's how they can insert an image of something they wrote on the picture inside the Markdown document. And in addition, they can compute, you know, various things in R and so on. So it's really very, very powerful. It's very easy to also use LaTeX expressions inline and display style. So hopefully you'll find that useful as well. And by the way, let me go back to the test. So this is how easy it is to add LaTeX. So, you know, there's no need to add any sort of additional text preambles. You just start with the LaTeX expression. Let's say display style E is equal to MC squared, there you go. And you sort of get a preview of the formula. Of course, when you need the document, this formula will appear, sort of the typeset mathematical expressions will appear in the document. And you can have inline expressions. So most of the things you can do, of course, in LaTeX, you can do directly in the Markdown document without much problems. Now, let's see, the Markdown Workshop I showed you, right? So the senior, oh, so by the way, from this Markdown document, I created a PDF that you can see. So this is a PDF, the PDF version of the presentation, basically. that I showed you, with pretty much absolutely everything the same: text, code, examples, but from the same source document. You see the power from the same source file. You can create lecture sort of format, lecture style notes or presentation, project reports, what have you. Okay. Now, there's also an HTML version. Of course, you can open it, you can view it in the browser. So you can actually see this is the HTML version created again from the same source document of my presentation that I had. So this is the same material, the same text, everything, code, examples, and everything is sort of with a, but now in the HTML version, I have some additional features here, for example, a preview of Kurt Bryan's book. Just the cover, of course, and so on. And this is a standalone HTML document you can post on a website. I post these standalone HTML documents on Blackboard that I use for my courses, and it's just very convenient. And I prefer using HTML so that the PDFs, they don't sort of get around the internet, especially for exams. And also I figure out a way when I create HTML exams to insert some a chunk of HTML code that prevents students from copying and pasting, from basically sharing these documents, from printing these documents. And this is, of course, the most useful for exams, because we don't want our exams to, if they're PDFs, obviously they end up with all sorts of sites that students know very well where to find our exams, and obviously that's not good. So there's some kind of additional security features that you can add in the Markdown documents to prevent students from copying, printing, especially when it comes to even watermarks. You can insert watermarks and so on to prevent students from spreading your exams around the internet. Now, how much time do I have? Not much. Okay, so in the remaining couple of minutes, let me say a couple of things about Python. So at the end, the last section is dedicated to, there's a Python implementation of the SIR model. This is based on the Primus paper. So there are basically a couple of ways to start using Python in RStudio. One way, if you're on the RStudio Cloud, if you go to the global options under tools, there is a Python here option, and you can actually select a Python interpreter that is available. There are also virtual environments and Conda environments, and you can sort of use these on your on a local computer, locally on your personal computer. One good way to get Python is either just to sort of install Python directly on your computer, or to install the Python, Anaconda distribution of Python. And then once you have that, of course, then you need to install the reticulate package. So the reticulate package that I mentioned earlier sort of provides the interface to Python. And then there are some details a little bit that you can look up from the reticulate documentation that I posted here. If you go to this link, you can actually find sort of all the details that you need. But basically, you need to learn how to manage, Python environments. And so here, and you can use the reticulate package for that inside a chunk of R code. You can create a Conda. Here, I created a Conda environment called rreticulate. And then in this environment that gets activated, then you can install any packages. So for example, here I installed NumPy, Matplotlib, and SciPy. And then you can use that environment. And then you can just sort of import, whatever packages and functions that you need, and you can start working with them, and that's it. So of course, it takes a little bit of playing around to get used to it. They keep changing things as well, but they keep making it easier and easier to start using Python. And I think at this point, it might be even easier than, let's say, using Anaconda or, sort of even Jupyter notebooks. And this is, again, a form of Jupyter notebooks, but it gives you much finer control when it comes to creating publication quality documents. And you can also use Jupyter notebooks on the RStudio Cloud. I think I mentioned that. And with that, I think I kind of covered very quickly most of the things that I wanted to talk about. Of course, if you have questions, please feel free to ask. I'm happy to answer. And again, you can download, so feel free to use all these materials that I've posted here. Let me show you how you can download them. I think that's important, right? So just put a check in front of, so here, inside the files directory, you put a check in front of or you can just download actually the entire project. But if you, let's say you want to download individual documents, then you sort of put a check on them. And then there's this, the settings wheel right here that says more, right? You click there and you click export, and then you click download, the download button. There's a download button. That's it. It downloads actually, if you select several files, it downloads a zip folder with these files that you can unzip and so on. If you want to upload a document, obviously, there's this upload button here. You can click on the upload button, then you can select file from your computer. You can upload it there. You can rename files. By the way, it's very important to know that our RMD files do not like spaces and any kind of special characters, and that could create problems that you wouldn't be able to figure out what's going on, where the problems are coming from. So you just keep it simple when you're naming these Markdown files. And you can also see in the working directory here that when I created the reticulate environment, you see the folder here, reticulate. So that's the Python conda environment. And before that, I had to install miniconda. So that's why you see the miniconda package. You can also create virtual environments. So the reticulate package allows you to create virtual environments, conda environments. And of course, if you're a big fan of the terminal, there's also the terminal here. You can install everything from the terminal. I mean, when it comes to Python packages, installing Python packages and all that, right? And you can just download the entire RStudio project here. If you go back, to the shared workspace on the right-hand side, there's some options that allow you to download, the entire R project with all this, the entire directory here with all the files and everything. Yeah, that's it. So, I mean, my time is up. I'm happy to take questions, and I'm happy if you use these files to some benefit. I hope they're useful. Let's see, the visualization of the family of solutions of the, it was really nice. Oh, yeah, thank you. Yeah, okay, sure. Yeah. I hope you use these materials. I hope you find them useful. That's why I'm sharing them with you. I want people to use them. One thing to mention though, please do not play in this shared space. Download the entire project. So by the way, you go here and you can download, the entire project. You see these options here. This download button on the right-hand side. You just click on the download button. It will zip the entire project and it will download it. But because I'm using actually an instructor's account, which is paid account, and I have a limited time. I have actually kept on the time. So please don't spend many hours in this shared space. You can just sort of download the entire project, and then you can move it. Actually, the best thing to do is just move it to your personal workspace that you just created, because you created when you create a free RStudio account. Look, there's this move button, right? So you click on the move button, the card, and then you can move it to your workspace. So you select your workspace, and that's it, okay? And then it will move the entire project to your personal workspace, and then you can sort of spend as much time as you want, okay? So I think that was an important thing, because, yeah, because I have these time limits. Let's see, let me look at the chat. Oh, okay, yes, look at Brian's book. It's really great. Yes, I love it. Right? It's very good. And I actually implemented a lot of his projects in R that way, in Markdown documents. And I was planning to share them with Simeon. I was talking to Brian about that. So we'll actually share, a lot of the projects that from Brian's book on Simeon that I developed in Markdown documents. I hope that will be useful. Right, so yeah, this actually visualization that he has in his book, and when I saw it, I said, okay, let's see, how easily I can do that in RStudio. So, and I showed you, it takes just a couple of lines of code. Okay, any other questions? Anything else that you're curious about? Let's see how many members I have now. 11. Oh, that's not bad. Okay, okay. 11 members. Pretty much everybody actually became a member. What is the question? How well does R deal with Laplace transforms? So to be honest, I haven't played with Laplace transforms, but I'm pretty sure the Pragma package probably has functions related to Laplace transforms. I can look into that if you're curious. I can look into that. And if not the Pragma package, I'm sure there are other packages because there are more than 15,000 R packages. So you can find R package nowadays for anything. In fact, there's an R package that I use to send emails. I manage my emails now from RStudio. And so I'm pretty sure, I've done Fourier analysis using R packages. So I'm pretty sure you can also find Laplace transforms there as well. Any other questions? Well, if not, I suppose I can stop here. It's 5:50 now, but I'm happy to take more questions, of course. Anything that you might be wondering, curious about. I can tell you about the instructor's account if you're curious. The student's account. So my students are setting up free accounts. But I have an instructor's account. Now the instructor's account is very reasonably priced. I have unlimited time, unlimited hours, unlimited projects, unlimited everything. And it costs $15 a month. But this is where, of course, the trick is, it depends on because this, when I create virtual classrooms, these are shared workspaces. And if my students spend a lot of time in these shared spaces, all this time, then there's actually a limit. Then there's a cap. And if I go above that cap, then the price could go into the hundreds, of course. So there's a little bit of risk there, but so far it's been, once I explained to the students exactly what the limitations are, they've been very careful sort of to avoid getting me charged hundreds of dollars for that. So I've been paying mostly $16, $17 a month, even when students are spending time, but not too much time. Because this is a shared space. So for example, this space that I shared with you, that's like a virtual classroom, right? It's a shared space and it has sort of a cap on usage. You can also adjust various resources in terms of CPUs, memory, and things like that if you have some more kind of computationally intensive projects to work with. Any other questions? You can write in the chat or just feel free to unmute yourselves. And if that's all, then, well, thank you for coming. And I hope you find this useful. I hope you use these files that I shared with you. Oh, what's the question? Can you cease to? Yeah, right. So that's a good question. Yeah. So yes, when a student creates a copy of the project that I shared, it's a derived project that I can join and I can see what they've done. But we cannot be in the derived project at the same time. And this is the collaboration feature that RStudio Cloud is working on. And they're going to release this feature very soon. And then when they do that, then I can join we can both, the student and I can join the derived project that the student derived his own copy or her own copy, and then we can work together there, very much like working in a Google document together. But right now I can see what they've done, but we cannot be at the same time in the project, like in Google Documents. I hope that answers your question. Okay, I have like four enthusiasts left. Ask more questions if you want to. I'm happy to answer. So I see here that basically, 6 students have created 6. Well, you're the students. So 6 people have created copies, 1, 2, 3, 4, 5, 6, 7 with me. All right, well, I suppose I have to stop at some point. I don't see any more questions, so I will.
I do think you might have one more question in the chat.
Oh, let me take a look at the chat. Oh, let's see. Yes, it does. Oh, okay, thank you. Yes. Have you tried? I have tried, yes, bifurcations and phase. Yes, I have done that in R. I've implemented bifurcations in R, and it was a lot of fun. And it's also, you know, I think I managed to do it in like 10 lines of code or something like that. So maybe it's not exactly 10, but not 100, certainly like 10-ish, you know, very compact, very compact. I do vectorize my code though. So I always kind of try to avoid looping things around. So I'm a fan of functional programming, and R is a great example of a programming language, even though it's not a general purpose programming language like Python, it's a statistical programming language, but it has features of both procedural programming and functional programming. And I'm a big fan of functional programming, meaning sort of, you know, working with functions on vectors and matrices rather than kind of looping things around. And that makes things very compact, easier to understand, also because it looks like mathematics, the way you would do things mathematically. And this is one thing that I kind of try to teach my students to really, you know, try to come up with vectorized implementations. And sometimes, of course, it's difficult, but it's always fun trying to vectorize your code. And it's very compact, easy to understand, and often really mimics what you'll be doing mathematically on a piece of paper. What is this? What's a good tool to learn how to vectorize your code? Oh, tool. There's no really tool. It's just it's really a way of thinking, you know, because R allows you to. So everything in R is already all R functions are vectorized. I mean, everything that is R-based is already vectorized by, you know, by design, right? Oh, you mean a book? Oh, I'm sorry, a book. Oh, you know, interestingly, I haven't come across a book that emphasizes this sort of functional programming approach. There is one book though that has a chapter on functional programming, and it's called Advanced R. So it's actually freely available. If you Google Advanced R by Wickham, he's actually the chief scientist of RStudio. And he published this. You can buy also a hard copy, but he created also a book down version, you know, using the book down package, of course, an HTML version, which is freely available. So you can explore Advanced R, and it has a chapter on functional programming. But I haven't really seen sort of, you know, kind of on the pedagogical side, textbooks using this approach. They all kind of emphasize the traditional procedural way of thinking with loops and things like that. I've been a big fan of functional programming for a long time. I started with Haskell, then kind of moved to F# a little bit. I mean, they're pure functional programming languages. And I'm a big fan because doing functional programming, like I said, is very much like doing mathematics. And it's a great way to combine mathematics and coding. Yeah, I definitely recommend starting with Advanced R, and then you find other resources, I'm sure. Okay, sure, yeah, thank you. Thank you, you're welcome.
I think if there are no more questions, I think we are good to go. Thank you for an amazing talk and for answering and staying late answering everyone's questions. Sure. And everyone on the call, thanks for engaging and asking questions as well.
Yeah, thank you.